Hi guys, in this video we're going to apply multiple regression to this data set. This is a data set that we saw in the Introduction to Multiple Regression lecture series, and we also saw output for this data set as far as multiple regression output was concerned. We created two models on this data, and we're going to go through all those calculations and computations using Google Sheets here, and I'll show you how we got all those numbers, and then you can go back and cross-reference and see that you get the same values that I get on this video, and that those values also equal the values that we looked at in the output in that lecture series. Okay, so just to remind you very quickly, this data set was concerning pie sales at a pie company. Okay, and we have a few variables to work with. So since we have more than two variables, this is called multivariate data. If you remember, we wanted to predict the pie sales, and we wanted to use some combination of the rest of these variables in order to predict pie sales. So right off the bat, we know that this is our y variable, and that the rest of these guys are at least potential predictors, potential independent variables that we can use. So in the first case, you recall I used price and advertisement in the first example. I didn't even discuss holiday until very later in the series of lectures. So let's just forget about holiday for now. Let's try to predict how many pies we're going to sell in a week using how much we charge, the price, and how much we spend on advertisement. Remember, advertisement it was in hundreds of dollars, so you could think of 3.3 as actually being 330. Okay, so we spent $330 this week, and we charged $5.50 for a pie. And in this particular week, we sold 350 pies. Okay, so that's one observation in this multivariate data set, and we have 15 observations if you count it. Okay. Also, one thing to point out, that this was a randomly selected 15 weeks. This is not in any special order here, in any chronological order. That's important because if it was in order, all of a sudden we have another problem called autocorrelation, which occurs when we collect data oftentimes over time. So we don't have that problem. These are 15 randomly selected weeks. Okay, so let us get the output for multiple regression, or let's run the multiple regression for this y variable and these two x's. So we go to Addons, Excel Miner, and Start. So if you don't have Excel Miner, you need to obviously install that one time, and it should go with you everywhere you go. Alright, so we're going to scroll down until we find linear regression. So this is the same linear regression that we used in simple linear regression. Okay. The y range is obviously our pie sales. Don't highlight the y variable and the name of the y variable. It'll confuse Excel Miner. Just one label is what it wants. Okay. Yeah, sorry. The x variable, there's actually two of them. So you need to make sure that they're next to each other. So in this case, since I'm only going to use these two guys, they're next to each other. That's fine. I don't need to do anything. But if one of them was here and the other one was here, and I wanted to use these two, I would have to do some copy and pasting, cutting and pasting, and get them next to each other before I get to input their range. Okay, so I'm going to highlight these two guys. They're next to each other, no problem. Okay, I have labels, so I'm going to check that. I'm going to go ahead and uncheck confidence level just because I want to minimize the amount of output I get. Okay, now where do I want this output? Let me throw it right here so I can see it all on one screen, hopefully. Just make sure you have the right inputs. Y should be this column. X's should be these two. Okay? Check that yours is the same. And then labels, because I highlighted the labels. Okay? Hit OK. When we started playing around a bit, I messed up the output range. Let me undo this and run this over. Okay, here we go. I was getting the right output, just I didn't want to overwrite my data. Okay, so look, we have a bunch of interesting things here, and if you recall quickly, let me just highlight some of these important stuff here. So I'm going to highlight R square, adjusted R square, the coefficients, the p-values that we use for all our hypothesis tests. Okay, so obviously a lot more decimal places than we saw in the slides, but that's only because, I mean, you can minimize those decimal places if you don't want to look at all of them. But here are our coefficients. Here's B0, B1, and B2. So I could put that all together here. I could say sales hat, because it's predicted sales, equals 306.53 minus 24.98 times price plus 74.13, I'm just rounding to 2 decimal places, times advertising. And I just extracted from this output my regression equation. Okay, so we went through the process of interpreting each one of these guys. Okay, so we even made predictions. So I can make a prediction. Let's say I'm charging $5.25 for a pie, and that pie is, and we're going to spend $360 on advertisement. Remember, I have to put 3.6 if I'm spending 360 because of the way the data was recorded, right? I need to pay attention to that. So what's the predicted sales when I charge this much and I spend this much on advertising? Well, I could do it by hand, or I could just use a little bit of the cell referencing. It's this guy plus this guy times this guy plus this guy times this guy. If you didn't see that once, just rewind and watch that again. I'm just plugging these two numbers into the equation that we just came up with. So that's how many pies I'm expected to sell, or predicted to sell, rather estimated to sell, if I charge this much for each pie and I spend this much on advertising. All I did was I plugged this number into price and this number into advertisement in this equation. I just used cell references instead. Okay, so I got the exact value here. All right, what else? Here's R square. We've interpreted that. So 52.15% of the variation in pie sales is explained by price and advertising. Here's adjusted R square, as expected, slightly less than R square, right? That's adjusted for the number of independent variables and the sample size. Here's the sample size, by the way, 15. Okay. Here's the p-value for the overall f-test. So we would have rejected HO for the overall f-test. We did all this in the lecture series, 4 parts, where we went very slow and we wrote out the hypothesis and made the decision and so forth. I'm just quickly recapping. I'm showing you how I'm getting these numbers rather than going into too much interpretation. And here are the p-values for the individual t-tests. Okay. Here's the p-value for the slope of price, and here's the p-value for the slope of advertisement. Okay, easy to find most of this stuff. A lot of these other numbers we're going to kind of ignore, and they're actually build-ups to these numbers that we're talking about. Okay, so that's how we got the output for the model, where we wanted to include price and advertising as predictors. Now, how about if we maybe want to come up, maybe we're not too happy with this R square or adjusted R square, and I wouldn't be too happy. I certainly wouldn't stop here. I want to come up with a good model, a model that does a good job at predicting pie sales. So if I see 52% of pie sales are explained by price and advertising, I'm not terribly satisfied. I'd want to try at least to make something, a model that's better, more predictive, okay, or better at predicting. So if I have some other X variables available to me, I might want to play with them. So I do. In this case, I have holiday. So maybe I want to include holiday too, not just price and advertising. So in this case, if you allow me, I'm going to copy and paste this into a new sheet so things don't get too messy here. I also want to include holiday, but the problem with holiday is it's categorical. Okay, we also have that issue to deal with. So I need to make a dummy variable before I include it. So what I'm going to do here is first off recognize that holiday has 2 levels. So in order to make it a dummy variable, I have to select one of those levels as a baseline, and I'm going to end up with 1 dummy because there's only 2 levels. So which of these to choose as a baseline? Let's make it clear. I'm going to choose no. Typically, if it's a yes, no is a nicer choice, but it's not necessary. You'll get the same results, just interpretations become slightly different. Okay, so if my baseline is no, I name my column the other level, yes. That's not terribly informative name for a variable, even a dummy variable. So I should probably add yes and maybe holiday. That's much more descriptive. Someone looking at this data will be able to understand what I mean by yes data. But yes would be way too vague. Now, since I've chosen no as my baseline, yes becomes my dummy, and there's only one dummy to make because there's only yes or no. If there was a third level, like maybe, then I would have to make another dummy for that as well. Okay, but we don't have that issue. So yes, holiday. Now I go through each observation. I have 15 of them, and I give a 1 if this is present, yes is present, and a 0 if yes is not present. In other words, if it's no. So 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0. Okay? So I didn't just randomly type those numbers. Okay? So I've created a dummy variable. Now if I had thousands and thousands and tens of thousands of observations, I definitely wouldn't want to do that manually. So let me at least show you how you could automate that if you had to kind of do this for a large data set. You could use the if function. I could say if this cell equals yes, then type 1. If not, 0. So this is kind of maybe if you're not used to the if function, maybe this is scary to you. You don't need to do this. It'll make your life easier though, because you see basically it just went through the same kind of logical process I went through when I was typing 1s and 0s, except it automated it. So let's just check that it did the right job. Everywhere you see a yes here, you should see a 1. Okay, and we do, so everything is fine. Okay, perfect. So now we've created our dummy, and now we can even call this guy x3 for ourselves. So I know I'm gonna include this guy, and this guy now to try to predict this guy. So I'm making a bigger model than the previous one. Okay, so in this case, I have one more issue that I have to deal with, because as soon as I go to add-ons and I want to just throw all this stuff into Excel Miner wants all the independent variables to be together, contiguous. Okay, I have a problem here. This is not going to be accepted by Excel Miner. I'm going to get an error message. That's why we created the dummy. So I need to get this guy out of the way so that this guy is next to these two guys so that I can input them all together. Okay, so I'm just doing a little moving things around. One danger with this is if you just did this with a formula. when you copy and paste things that have formulas in it, weird things can happen. To protect against that, we should probably copy all these numbers. So I'm doing Control C, and then I'm going Edit, Paste Special, and then I'm going Paste Values Only. Nothing will change visibly, but if you click on these numbers now and look in the formula bar, you'll see actual numbers there, hard-coded, and no if formula. So if you use the formula to get these zeros and ones, like I did, if equals if, you basically, in this process where we copied them and then pasted them in the same spot, but pasted them as values only, paste special values, we've basically hard-coded them. This way, now when I copy these and move them somewhere else, or cut them and move them somewhere else, I don't have to worry about the formula updating and changing things and getting all screwy. So if you actually typed 0, 1, 0, 1, 0, 0, 0, that's fine. Okay, this is not an Excel course, or rather a Google Sheets course. We're using Google Sheets as our software. So if you hard-coded them in, like I was just doing right now, and I erased, you don't have that issue. So so if you did use the equal if function, you copy, edit, paste, so first copy, then edit, paste special values. Okay, now you're good to go. Our next step is we can either delete this guy or just move him. We're not going to use him anymore because we got all the information we want out of him. We can just throw him over here, then cut both these guys and paste them here. Okay, all this was because Excel Miner, this guy that we're about to use to do all the heavy lifting, needs all the X variables that we want to include to be next to each other, with no kind of extraneous stuff in between, no gaps, no other variables in between, only the ones you want to include in the model. Okay, so that's all we did here. All right, now I got them all in a row, and I'm ready to go to Add-ons, Excel Miner, Start. My Y variable does not change. My goal has always been to predict how many pies we're going to sell in a specific week. Okay? The only thing that's changed is now I'm including more information to try to predict pie sales. I'm including another variable, another independent variable. Whereas before I just used price and advertising, now I'm going to also use information on whether that week had a holiday in it or not. Okay, I would expect from the outset that if there was a holiday in a specific week, that would cause pie sales to probably increase, right? That's my idea. Okay, let's see what happens. Okay, so I come over here, I still go to linear regression. My Y is still pie sales. Okay. My X, however, now is not only price and advertising, but also yes holiday, which I spent some time to get yes holiday, right? I had to do some pre-processing work to get yes holiday from holiday. Okay, make sure I get all that correctly in there. It's a little clunky. Select labels. You can uncheck confidence level. Only thing left for us to specify is the output range. Let me throw this all over here. Okay, if everything looks right and didn't change, remember this is a little clunky because it's all online, right? So sometimes it lags and you get all kinds of weird things happening. But just slow down, get this right, click OK, and we should get the correct output. Okay, I could close this and now focus on my output. Okay, let's resize a little bit. It shows me tons of decimal places. So if you don't like that, spend some time and delete some of these decimal places. Let me highlight some important things for us again, just so your eyes get trained to find the correct, the important output that we've discussed in the lecture series we did. Highlight these, maybe in a different color, okay? Because this now is the second model we built on the same data. We tried to predict pie sales one time in the previous sheet using just the price and advertising. Now we're trying to predict pie sales using price, advertising, and whether it's a holiday or not. So that's two models that are trying to do the same thing. You could see where this is going. You're not going to keep both of them. What you want to do is pick the better one. Okay, so that's where we're going. And you kind of already know, if you watch that series, that adjusted R-square is going to be our tool to decide which of the two models is doing a better job at predicting the Y variable that we're interested in predicting. Okay, but before we do that, let's pull out the coefficients and write the multiple regression equation. So sales hat, that's still our Y, and it's hat because this equation predicts sales, doesn't tell us what sales will be exactly. 415.10 if I round to 2. I'm getting all this from the coefficient section. Minus 17.29 times price. So price has a negative impact on pie sales, not a surprise. 16.34 times advertising. Advertising has a positive impact, no surprise there. Plus 89.43 times yes, holiday. So it turns out if it is a holiday, if it's a holiday, that meant 1, right? So I would plug in 1 here. If it is a holiday, pie sales are expected to increase by that much than if it isn't a holiday. Okay, and that's our multiple regression equation. I pulled all this from here, the coefficients section, and I correctly labeled the variables. Instead of calling them x1, 2, 3, and b0, b1, b2, b3, I used the correct names, and also instead of y hat, I used sales hat. And the hat is important again because this is a predicted sales, right? So let's make a prediction quick before we look at some other things. So let's say we're going to, the price we're going to charge is $5.25. I think that's what we charged in the last case. We're going to spend $360 that week on advertisement, so that's 3.6. Why? Because that's how the data recorded advertisement. Okay, you have to adjust yourself. There should be a clear sign here. Actually, there isn't, but if this is a follow-up to the lecture series where we talked about this to a great extent, we focused on paying attention to how the data is recorded. This happens a lot in financial statements. Sales are kind of reported in thousands. You need to be aware of that. Okay, so 3.6 with this data actually means $360. And finally, we need to also specify whether it was a holiday or not. So let me say holiday. Yes, it was a holiday that week, or there was a holiday that week. Okay, so what is the predicted sales if these are the features of the week? Okay, so what's the predicted sales? So sales hat. So we're basically just going to plug in all these guys into their appropriate place in the equation, except the yes becomes a 1 because that's how we coded yeses. So we can't plug in yes. That doesn't make sense to plug in a word into an equation. But that word gets converted to a number, in this case 1, because we went through that whole process of creating a dummy variable. We chose no as the baseline, so no meant 0. 1 meant yes. So we plug in 1 here. So let's see what happens. So instead of writing the numbers out, I'm going to just click on the cells. This guy plus this guy times this guy plus this guy times this guy plus this guy. And I want to say times yes, but I can't times yes. But yes means 1, so times 1. So predicted pie sales are going to be we're predicted or estimated to sell 472.57 pies when we charge $5.25, spend $360 on advertisement, and there's a holiday that week. So if I was the kind of manager here, I would have to kind of make sure I have enough inventory, have enough staff to handle that kind of volume. Okay, so you could see how this stuff can kind of get used in different ways. These predictions aren't just for fun. They can actually have actionable consequences. Okay, so that's how we make a prediction. All I did here was use references to plug these numbers into this equation. Okay, I referenced these guys and these guys. Okay, now, of course, we can spend some time interpreting R-square. Obviously, you see R-square went up considerably compared to the previous model we did in this video, where we just had price and advertisement. But that was kind of expected, because if I add more predictors, R-square is always going to increase. So I shouldn't compare these two models with R-square, and I shouldn't be surprised that it went up. The overall f-test is still significant. In other words, we would have rejected HO for the overall f-test. The individual t-tests are not all significant. If you notice, the p-value for advertising is greater than 0.05, so we would have failed to reject there. So that's interesting. Okay, you can kind of slow that all down and write out all three of those hypothesis tests. You would reject for price, fail to reject for advertisement, and reject for holiday. Okay, so finally, what we want to look at, though, what I want to focus on is the adjusted R-square. So adjusted for the number of predictors and sample size, 79% of the variability in pie sales is explained by price, advertising, and holiday. Now let's compare that to the adjusted R-square when we only considered price and advertising and not holiday. Adjusted R-square was considerably lower. So that's telling me that adding holiday to this model made it a lot better at predicting pie sales. Of course, when I say adding holiday, I mean adding the information, the variable of whether it was a holiday that week or not. Added a lot of prediction power. We went from 44 to about 79. That is considerable improvement. If I was the person building this model for the manager, the boss, or if I was the boss myself and I was kind of trying to come up with a good prediction of how much pies we're going to sell, I would definitely keep this model, the one with holiday, over the one without holiday. So in this case, the bigger model turned out to be the better model. But don't take that for granted. That's why we use adjusted R-squared. It's not always going to tell you the bigger model is better. In this case, the bigger model was better. So that is the conclusion. In some cases, the bigger model can produce an adjusted R-squared that's actually lower than the smaller model. So don't take it for granted. Okay? All right, so that this tutorial was to show you how I got all the values from the lecture series on Introduction to Multiple Regression. So you know how to get all those numbers and create a dummy variable and where to find all the important output in Google Sheets. Excel has a very, very, actually identical output to Excel Miner. So you can also do this in Excel using the data analysis tool pack. You could replicate all these values, and you can also get values for yourself on a lab or on any data set that you want to run a multiple regression model on. So I hope this was helpful. Till next time, have a great day.